question number 8 says, what is the domain of the function? This is an exponential graph, and there are transformations. So let's go ahead and just do the transformations first. So h of x equals negative 4x plus 2 minus 7. Well, my parent function is that 4 to the x, so this is all my parent function, so everything else must be a change. So that negative tells me a reflection over the x-axis. That x plus 2, remember, tells me the opposite, so it's left 2. And that negative 7 is going to tell me down 7. So I have an idea how this exponential looks. It is a reflection. The graph is moved down, so it looks like this, essentially. But the domain for exponentials is always going to be x and element of the reals. The domain will never change based on the transformations, but the range will. The range is going to change based on things that move up and down and based on reflection. So normally, the range is y is an element of the reals such that y is greater than 0. But I've moved this down 7, so now it's going to be a negative 7 there, and the reflection is going to flip that graph over. I'm sorry. So it's going to make it y less than 7, and then it's going to be y an element of the reals such that. So it's normally this, y greater than 0, but I moved it down 7, so that's a negative 7, and then I flipped it over so it became a less than instead of a greater than. Make sure you do your curly brackets, and that is your answer. Okay, same thing for the next guy, also exponential. Let's go ahead and do the changes first. Alright, well 2 to the x is my parent function, which means that this does something that's actually going to stretch it by a factor of 3. You can see the answer key, but stretch by a factor of 3. And this is also in the exponent, so that's going to be moving left and right, and it behaves the opposite of how you would expect. So that guy moved right 4. But again, nothing changes the domain, so still it's an x element of the real. And what is the range of the function? Well, I didn't move it up or down, and I did not reflect it. So this guy is fine. He's going to be what the original range normally is. Y, I'm sorry, I keep getting off the paper there. Y is greater than 0. Number 10, you can read through this question, but I'm going to look at this equation here, and it's asking me what is the rate of change for the population per year. We're looking at 1.0126. Firstly, it's higher than 1, so it's going to be an increase. So all these decrease answers are not even a possibility. And then the increase. This is 1 plus 0.0126. I want to change that to a percent, so just move it 2 places to the right or multiply it by 100 in the calculator. I get 1.26, and so it's 1.26% increase. Same thing for number 11. Here's my equation. It's less than 1, so therefore it has to be a decrease. And then it's 1 minus something is 0.965, so firstly it can't be 1 minus that. But it's 1 minus, if you do the math, you get 1 minus 0.035, which is, move it over 2 places, 3.5%. Alright, going to chapter 11, we're going to be talking about polynomials and stuff. So this one says add or subtract, so I'm going to be subtracting. Just distribute that negative sign to each of those things in that trinomial. And then just combine like terms. So 8 minus 2 is 6x squared, so that's gone, that's gone. 3x and 3x is a positive 6x, and then a plus 8. Just combining like terms. Make sure, though, that you're careful about that negative sign there. Okay, moving over to this guy. I'm just going to distribute that to be negative 4x squared and plus 8x, and then everything else is fine because it's positive. I'm going to go in order. I'm going to go x cubed. So that guy's taken care of. I'm going to go x squared. 7 and a negative 4 is a positive 3x squared. And then x's, so 2 and 8 are 10. And lastly, negative 3. Okay, multiplying, don't forget, you can use the box method, but I'm just going to multiply x times all 3 of those. So I'm going to get 4x to the third plus 10x squared plus 6x. So that's x times all 3. Then I'm going to take negative 1 and also multiply by all 3. And I'm going to line it up. So I'm going to get negative 4x squared, a minus 10x, and a negative 6. I like lining it up on top of each other so I can easily just add straight down. But it doesn't matter how you do it. As long as you get 4x cubed, a positive 6x squared, a negative 4x, and a negative 6. Alright, this guy, hopefully you recognize, he's an a plus b times a minus b scenario, so he should end up being a squared minus b squared. So I could easily just automatically see that it's 9x squared minus 4, but let's go ahead and do the math. So there's times that. You get 9x squared minus 6x. Do 2 times both of those, you get plus 6x minus 4. Middle terms cancel, and there's your 9x squared minus 4. Just be mindful that later when you start factoring, 2 terms, difference of perfect squares is always going to be whatever plus the number, whatever minus the number. So a plus b, a minus b. Alright, this one, probably going to be the most missed one out of all of these. This squared means do it twice. Multiply, you're going to get x squared plus 3x plus 3x plus 9. X squared plus 6x plus 9. Alright, moving on down. Finding the perimeter, you're just going to add up all the sides. Make sure that you account for, there's 2 of these and 2 of those. Just add up all your x's. 5x plus 5x plus 7x plus 7x is going to be a 24x. 2 plus 2 plus 1 plus 1 is 6. Tag on your unit. Centimeters. Done. Perimeter's pretty easy. You don't really need to write much down. Just add them up. Okay, area of the triangle. Area equals 1/2. It told me that base, well, I mean, here's my base, is x plus 1. And it told me my height is 2x minus 6. So A equals, and just distribute. So do your x times that and your 1 times that. So you're going to get 2x squared minus 6x plus 2x minus 6. A equals 1/2. 2x squared, oops, I almost put the wrong thing. Negative 6x and a positive 2x is a negative 4x minus 6. I'm just going to cut everything in half. So A equals x squared minus 2x minus 3. But this is area, so it's going to be units squared. Alright, find the area of the shaded region. Keep in mind that the shaded region formula is whole minus part. So the area of the whole is length times width. So the area of the whole is x times 2x plus 3. The area of the part is base or length times width, so it's 3 times x minus 2. Well, this is going to be 2x squared plus 3x. This is going to be 3x minus 6. But I want to do the whole minus the part, so I'm going to do the whole minus the part. Just basically take into account these are minus. These are being subtracted. So it's going to be 2x squared plus 3x minus 3x plus 6. 3x minus 3x cancels. You get 2x squared plus 6. And it's area, so it's units squared. Alrighty, going over here, find the area of the shaded region. Same exact scenario, just a little bit more complicated sides there. So still area of the whole minus the area of the part. Whole is 2x plus 3 times 5x plus 6. The part is going to be 2x times x plus 1. Going to work my way through this guy. So it's going to be 10x squared plus 12x plus 15x plus 18. Clean it up, 10x squared plus 27x plus 18. So that's the entire whole part. Then I've got to find my part. 2x times x is 2x squared plus 2x. I want to subtract this, so minus 2x squared plus 2x. Just keep in mind I'm just basically distributing that negative sign. Then just combine like terms. 10x squared and negative 2x squared is going to give me a positive 8x squared. 27x minus 2x is a positive 25x. And that 18 has no partner, so just plus 18. And again, area is units squared. All right, question 18 says, what is the greatest common factor of this guy? Just looking through, I see that 3 goes in all of them. And then looking at the x's, x squared, so we've got 6 and 4 and 2. You always take the smallest. And there's y squared, y, and y, so y is the smallest. So 3x squared y is the GCF. All right, factor completely. There are several ways you can factor. If you have 3 terms, you should always check for GCF first, but then you can do house method, guess and check, X method, whatever you want to. So I'm going to go ahead and factor out. These are all even, so I can see a 2 comes out, and there's an X in that guy, so I can see that 2X comes out. Divide each term by 2X, you're going to get 3X squared minus 8X plus 5. You can do house method. But I'm just going to guess and check. It's not really that much work to guess and check. The only way to get 3x squared is a 3x and an x. And then I'm just going to use my pencil. And if I get it wrong, I'll just fix it. So how do you get a 5? Well, it's 1 times 5. So I'm just going to try 1 and a 5. Check your inner product. I get a 1. Outer product, 15. There's no way to make 1 and 15 give me an 8. So I've clearly chosen the wrong thing first, which is okay. So I'm just going to swap it around. Put a 1 here. Put a 5 here. Inner product 5, outer product 3. 5 and 3 give me 8 if they're both negative. So make it a negative 5 and a negative 1. And there is that guy factored. Not too much work. I'm going to go ahead and do the one right below it as well, just because he's right there. If you ever have 2 terms, it's either GCF or it's a difference of perfect squares. So there's nothing in common, so it's a difference of perfect squares. It's going to be a plus b, a minus b. How do you get 4x squared? That's 2x and 2x. How do you get 25y squared? Well, that's 5y and 5y. Make 1 plus, make 1 minus. Check to see if you have a difference of perfect squares left over, but you don't. So you're done. Okay. Question B. This guy, there is no GCF, so you can do house method. I'm just going to go ahead and guess and check again. Again, it's not too much work. 3x and x don't really give me that many options. How do I get 8y squared? Well, it's either 1 and 8 or 2 and 4. So I don't really have that many options to check. I'm just going to try 2 and 4, because it's usually the closer together options. 2 and 12. No, 2 and 12 are not going to give me 2, so I've clearly chosen wrong again, which is okay. So now I'm going to try a 2 here and a 4 here. 4 and 6. Okay, coolio. 4 and 6 do work. I want to have a negative 2, so I need my bigger one to be negative, so I want an outer product of negative, but don't forget this y, so it's actually going to be 2y, and the inner product is positive 4y. So just be mindful, just factor like normal, and just tag on a y at the very end, and you're done. That's your answer. Okay, directly below it, you should always be mindful for perfect square trinomials if you can. If your first term is a perfect square and your last term is a perfect square, it's usually a perfect square trinomial. But I'm going to guess and check. So my options are 3 times 3 or 1 times 9, but I'm going to try 3x and 3x first. My options for 4 are 1 and 4 or 2 and 2, but it's usually the closer together options. So I'm going to try 2 and 2. Inner product 6, outer product 6. How does 6 and 6 make 12? Well, make them both positive, so plus 2 and plus 2. You would see this answer written like this, though, if you were to do it on multiple choice or whatever. But perfect square trinomials, usually the first term, and, well, I mean, they have to be the first term and last term are perfect squares, and the middle is actually a multiplication times 2. But you can guess and check just as easily as any other method. Okay, letter C is difference of perfect squares. So how do you get x to the 4th? Well, that's x squared and x squared. How do you get 81? Well, it's 9 and 9. Make 1 plus, make 1 minus. Good to go, except now I have another difference of perfect squares in this guy. How do I get x squared? It's x times x. How do I get 9? Well, that's 3 times 3. Make 1 plus, make 1 minus. And don't forget to bring down your first factor you had already done. So there's that guy. All right, and lastly, F. If you ever have 4 terms, it's probably factored by grouping. So just take out what you can out of the first group. The second group, whatever sign is in the middle has to go. So I got to take out a negative, and then they have a 4 in common. Divide both by negative 4, you get x plus 8. This one works. Whatever that common parentheses is part of your answer. And then your other part is whatever's left over. So x squared minus 4. Almost run out of time, but it's going to be x plus 8. And then x squared minus 4 is a difference of perfect squares. How do I get x squared? It's x times x. How do I get 4? That's 2 and 2. Make 1 plus, make 1 minus, and you're good to go.